All right, so we got basics XI, that would be 11. All right, basics 11. First one, I hope it goes better than it has been. We got a base, we got an argument, we got an exponent. 6 squared must equal 2x minus 10. 6 squared's been 36 my whole life. Don't expect that to change. The opposite of subtraction is addition. 36 plus 10 is 46. The opposite of multiplication is division. And 2 enters 46, I think, 23 times. Easy peasy lemon squeezy. 2 and 3, I hope these go better next time. Think about everything inside being to the first power. And then we're going to use power over root. So we're going to have 3x squared plus 4. The power is 1 sitting over the root of 5. Get that down. Like, this is how you cheat the TI-84 with radicals. That's how you do it. 7, solve this bad boy. Let's see, we have 6x squared plus 1 to the 1/7 equal to 2. And then we go to our TI-84 and we push buttons. Pretty sure I got stat plots on, so let me turn that off. Reminds me I need to reset all my calculators today. And I'm at y equals. What we got here? We got a parentheses, 6x to the second plus a 1. And g is rooftopped to the 1/7. Got to understand power over root. 2 and y2, zoom 6 that thing, and see what we see. Looks like it's one of these that has symmetry, which is cool. So it's going to have 2 answers, but I only got to know one of them, and I just use the plus or minus symbol. There we go. Solutions happen where graphs intersect. Most of y'all know that. Not everybody does. Anyways, I'm going to go after the positive one. Get close, enter, enter, enter. And we go, 4.6007. Because of the symmetry that thing had, we also have negative 4.6007. 4, solve the factored polynomial. It's just using the zero product properties, so x plus 2 is a 0, which means that x is negative 2. 3x plus 5 is a 0. Think about your 2 moves. 3x is negative 5, and then divide by 3. So negative 5/3. And the one with a little bit of work, 9x squared minus 144 is 0. You know, the first easy thing to do would be to add 144. The next easy thing to do would be to divide by 9, and that should generate a 36. No, 16. What's wrong with me? That's a 16. Anyways, opposite squaring is square rooting. Positive 4, negative 4. Don't forget that. A lot of kids forget the plus or minus part. This has been the same on 2 quizzes and 2 twins in a row. I ain't changing it. Nope, actually, this one did get rearranged. Hold on. But it's the same answers. So if f of c is a 0, that means x equals c is a 0. All right. If this is a 0, then x minus c equals 0. This becomes a factor. That guy. If I did long division, the remainder would be 0. And because the remainder is 0, we are said to enter it evenly. All right, number 6. Solve this thing by hand. We're going to divide both sides by 4. That's going to give me the natural log of 5x minus 3 equal to 5. The base of a ln, or a natural log, is e. Therefore, e to the 5th is now 5x minus 3 because we exponentiated. That's the name of the process. This is called exponentiating. The kids who know that word tend to do this. The kids who don't know that word don't. Its vocab is actually a big deal. Let's see, the opposite of subtraction is addition, and the opposite of multiplication is division. So there's my answer. E to the 5th plus 3. Now this thing actually is doable on a TI-84. You get half credit for it, but you could have just typed the blasted equation in. It was 4 natural logs, 5x minus 3, and then y2 is a 5. I think you would have had to look pretty far to the right to see the answer. Do a zoom 6. That seems too small. Oh, because it was equal to 20. Not 5. That's better. But this is a ginormous number. It is absolutely huge. That's e to the 5th plus 3. Obviously, you're going to have to look up because you have a 20 in y2. So let's just set a y max 25. And I'm going to go ahead and look out 100 units, even though I know that's not enough. I actually have no idea what e to the 5th is. Oh, I guess 100 units was fine. Yeah, because we're over a 5. So anyways, not a ginormous number. I bet it's close to 30, isn't it? Something wrong with me this morning. I did a second trace there. It happened really quick. Second trace 5. Enter, enter, enter. Yeah, 30.2826. You get half credit if you can just come up with that decimal. All right, determine the average rate of change from x equals 3 to x equals 8. So I'm just going to highlight those two columns. I'm thinking about the ordered pair of 3, 0 and 8, 12. Of course, I know slope is the difference in y over the difference in x. And I hope you do too. So the difference in y here is going to be 12 minus 0. Notice I'm working bottom up. I got to stay that way over 8 minus 3. And that's just going to be 12 over 5. And that's just where I stop. Don't do anything with that. You know, every junior is supposed to know the quadratic formula before you ever walk in my room. And this is never the case. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. I have probably sung that to y'all 50, 60 times. I don't understand why you don't know this thing. It doesn't make a lick of sense to me. Opposite of a negative 8 is a positive 8, plus or minus the square root. Use parentheses because you're button pushers and you don't know any better. Minus 4 times a, which is 2, times c, which is negative 5, all sitting pretty over twice 2. All right, let's see here. This is 64. A negative times a negative is addition. And then we got 4 times 5, which is 20, times 2, which is 40. So we got 64 plus 40, which is 104. 2 times 2 is 4, by the way. Now, root of 104 is divisible by 4. No surprise. It's going to be root 4, root 26, which is 2 root 26. 26's factors are 2 and 13, so she's done. It's both her factors are primes. 8 over 4 reduces to 2. Let's think about this guy sitting over 4. The 2 over 4 reduces. Root 26 sitting pretty over 2. Which the following is equivalent to the 4th root of 1296. I hope it's 6. Or something's wrong with my brain this morning, but I didn't sleep well, so, you know, who knows. The big thing is you recognize this is the most important one to know. It is. I swear it is. Because that's the one that's going to give you the real answer, and the real answer is 6. All right. It's amazing how many kids actually miss this problem when you're holding a TI-84. Like 216 cubic root, 1 over 3. I don't understand how you can miss it. I don't. It's the same thing. It's 6. Square root 36, 6. Everybody and their mama knows that, right? Actually, if your mama don't know, you don't know either, because the apple don't fall too far from a tree. Now, does it? Use synthetic division to factor this thing, given that f of negative 5 is 0. So we're going to throw a negative 5 out front. The coefficients are 1, 5, negative 9, and negative 45. And yes, I want you to use synthetic division to do it. Trying to get synthetic division in your head. The acronym here was DMA. We drop. Negative 5 times 1 is negative 5. 5 plus negative 5 is 0. Negative 5 times 0 is 0. Negative 9 plus 0 is negative 9. Negative 5 times negative 9 is 45, and that's a 0. Remainder, constant xx squared. We have x squared minus 9. Does she factor? Yes, she does. She is x plus 3 times x minus 3. And then we have this factor, which was x plus 5. And there is the complete factorization of that cubic. Given 3 terms of the sequence, negative 3, 10, 23, write a rule for sequence. Now, you know, I don't know why this is so hard. if I plug a 1 in, I'm supposed to get back a -3. It's that one. 13 times 1 is 13. Take away 16 is -3. Now, I'll just take off a point if that's all you can do. But I don't know why you miss these things. If I plug in a 2, I better get back a 10. 13 times 2 is 26. Minus 16 is 10. If I plug in a 3, I better get back 23. 13 times 3 is 39. Minus 16 is 23. It's this answer. I'll give you half the credit for it. I will. It'd be cooler if you knew the algebra. But I'm just going to plug into this guy over here. The nth term is the first term of -3 plus the difference, which is 13 times n minus 1. And I'm just cleaning it up. Let's see, I'd have a sub n equals -3 plus 13n minus 13. And of course, you can still see you get choice D. All right, for an arithmetic sequence is given as 2, 12, 22. Find the sum of the ford. What is the ford term? I should see a th there, right? The fourth, I must have changed it from 3 to 4. 4 through the 12th terms. You may use a formula to write it out. If you write it out, show me. There's nothing wrong with writing it out. Let's see here. It looks like the difference is 10. So the next one would be 32. Then we got a 42. Then we got a 52. Then we got a 62. We got a 72. We got an 82. We got a 92. We got a 102. Let's see. 4, 5, 6, 7, 8, 9, 10, 11. And the last one's 112. And then you would just go push some buttons, right? And you'd see what that is. Let's see. Should be 648 when everything's said and done. Geometric sequence is given as -3, 1, -1/3. Your ratio is going to be the second over the first if you don't know it. So it's going to be 1 over -3, which is just -1/3. You're supposed to write both a recursive and an explicit rule. They're right here off to the side, dum-dums. They are. Like, I have kids leaving this blank. I don't know how you breathe. First one's -3. If n is 1, again, my attention is right here off to the side where the frickin' formula is. And I am -1/3 times a sub n minus 1 if n is bigger than 1. I don't know why you'd be leaving that blank. What's wrong with you? The explicit rule right there, the first term of -3 times -1/3 to the n minus 1. Ta-da! 14 is a y1, y2 problem, plus 2 if you can do it by hand algebraically. A geometric sequence has a first term of 1, a common ratio of 4, and the sum of n terms is big. What is that, 3 billion? Or 357,913,941. How many terms were there? You're still going to do the setup. Okay, so this is S of n. So 3, 5, 7, 9, 1, 3, 9, 4, 1 is the first term of 4 times 1. Nope. First term is 1 times 1 minus the ratio of 4 to the unknown power of n sitting over 1 minus 4. Now I'm just going to do this thing by hand real quick. It can't take that long. All right, this is going to be a -3. And the opposite of dividing by a -3 is going to be multiplying by a -3. So let's see what that's going to generate. -3 times 357,913,941 is that number. A billion and some change, right? Yeah. So -1,073,741,823 is now equal to this, 1 minus 4 to the n. We're going to take away 1. And then I'm going to divide out the negative 1 as well. So first I'm going to take away 1. That's going to make, and this is negative, so that's going to make that a 4. I'm going to divide out the negativity, make it positive. And there we go. Now I can do a log. A log base 4 of all of this is n. Pretty cool. We'll have to use change of base for that, unless you happen to know what power of 4 creates a billion and some change. So we have the natural log of 1,073, or sorry, 1,073, 741,824, sitting pretty over the natural log of 4. 15. All that work for 15. All right, now here's how you do it with y1, y2. So you kind of go back to what it was originally, and you don't have to do any algebra at all. You just have to type this in your TI-84. Put that 357 million and some change in y1. I remember making this problem up, although it's not that hard. I think I got it typed in. Let's see here. Let's go to math, num, n over d. Of course, if you want that 1 out front, you can put it. You got 1 parentheses. Top is 1 minus. The parentheses here are just out of habit. It's not actually a requirement on this particular problem. And that's sitting pretty over 1 minus 4. Let's just pretend you have no idea what that is, because some of you don't. You'll do a zoom 6, completely frickin' worthless. Absolutely worthless. You're going to want to put about 360 million in for a Y max. I know some of us will struggle with that, but you're going to want to set a Y max of about 360 million. 360,123,123. That looks like 360 million. And just because I already know the answer, I'm going to set the X max to 20. When you do your actual quiz here, you know, keep an eye on what you did on the twin, because I'm sure they'll be somewhat similar. Sure. So anyway, second trace 5, enter, enter, enter. Ta-da! There she is, X is 15. Starting to get tired. All right, move. Speaking of 15, number 15, oddly enough, is the next problem. You're supposed to find the sum from where n is 3 to n is 10 of the sequence, or the series generated by the sequence, -2 times -1/3 of the n. And you're going to use this guy again. N is high minus low, add 1 back in that formula. So this is going to be 8. So I'm going to use 8. It's the sum of 8 things. Now, it talks about the first thing, and the first thing happens when you plug in a 3. So you actually need a sub 3. It's -2 times -1/3 cubed, which is, what, 2/27? Seems legit. I know that, oh, wow, Milbrath did some math. Okay, let's check my math. Let's hit math, enter, enter. 2/27. See? Told you so. Let's see, we have 1 minus the ratio. This is R. R is the guy with the exponent. We need that set of parentheses there. This is being raised to the 8th. And that's sitting pretty over 1 minus a -1/3. And then we just go push buttons on a calculator. I don't know if it's going to be able to give us a nice fraction on this one. I know I could do it by hand and get a fraction, but I don't know if it's going to. I think we'll probably run into its limitations on this one. Of course, 1 minus -1/3 should be 4/3, but let's just presume we don't know that. It gave me this funky decimal. Math answer frac. Yeah, it really couldn't do anything with it. So 0.0555. It isn't about because I had no choice but to round. All right. I think I'll probably stop at the end of this one for this part. Completely simplify the expression 55 e to the fourth x to the negative 13, sitting pretty over 35 e to the negative 7 x to the 14, such that all exponents are positive. Now, 55 and 35 are both divisible by 5. That's 11 sevenths. You think about your e to the fourth over e to the negative 7th. We just shift that guy with the negative exponent up top, and then we add exponents. E to the 11th. We have an x to the negative 13 sitting pretty over x to the 14th. Same idea. We shift the negative exponent down low, makes the exponent positive, and 14 and 13 is 27. Here we have a simplification. 243 does not have a fourth root. 243 is 3 times 81. So I'm thinking about the fourth root of 81 times the fourth root of 3. And the fourth root of 81 is a 3. So there's going to be a 3 outside of this thing. And there's still going to be a 3 inside of it, because I'm looking at 3 fourth roots of 3. Now let's focus on these pieces. 4 enters 17 4 times with a remainder of 1. So there's going to be an x to the fourth outside and a singular x inside. 4 enters 25 times with a remainder of 0. Easy peasy lemon squeezy. We have our logarithm one. This ain't been going so hot. I don't know why. Dakota Davis, I'd like you to figure this out. We got the natural log of 2x minus 6. She's sitting pretty over the natural log of 3, and then take away 3. This is going to be the ln of 4x minus 9, sitting pretty over the ln of 5, and then take away 5. Not that hard, really. We just don't want to do it. We got natural log 2x minus 6 sitting pretty over the natural log of 3. And then take away 3, something a lot of kids don't do. Sitting pretty over the natural log of 4x minus 9. Sitting pretty over the natural log of 5. And then take away 5, because it says minus 5. Zoom 6. Lord knows I don't want to use the last window I did in this video. It was huge. And solutions happen where graphs intersect. And they intersect really early on right there. So it's second, trace 5. We're going to get close. 1, 2, 3. There. Just going to press that cursor till I see her show up. Enter, enter, enter. And I'm seeing 3.1313. 3.1313. And the last one I'm going to do this morning, number 19, find the average rate of change for f of x shown below over the interval from -2 to 3. Bro, I'm just going to do slope. y2 minus y1 over x2 minus x1. It's going to give me 5 over 5, which is 1. Done. Drops mic, all that good stuff. I'll do the second part probably tomorrow. I don't know. But I'll get it done.